Today we're going to solve quadratic equations by factoring. To do so, we're going to recall what we know from last unit. We're going to use what we found to factor a polynomial. So first of all, let's go back and talk about that. On your test that you just got back, you had something that said x squared minus 5x plus 6. And you were asked to factor this trinomial. When we factored the trinomial, we made our table. What multiplied together to give us 6x squared, but added together to give us negative 5x. We found that that was the factors of what? 6 and 1, where 6 had to be negative to give me negative 5. So then I could take the shortcut that said x minus 6, x plus 1, and then I factored my trinomial. These are the factors of the trinomial. Today we're extending this because we're going to have quadratic equations, which means I'm going to create an equation. I can create an equation just by here equaling 0. Now, when I have this, there is something that's called the zero product property. With the zero product property, it says for all numbers a and b, a times b equals 0, then a can equal 0 and b equals 0. That means I can take these two factors, separate them individually to equal 0. Same thing I'm going to apply here. I have the factor x minus 6 times x plus 1. I am going to set each one equal to 0 separately to make two mini equations. Now I'm going to solve each mini equation. I have now found the answers to where what x equals to make this quadratic equation works. It's going to be two answers because I have an x squared. So therefore because my x is squared, I'm going to need two of them. Each one would work if I tried to check it. And because I have two solutions, I have to put them into set notation. Taking this knowledge, that's all we're doing on the first side of our notes. So, looking at example 1, and these directions up here just kind of reinforce that. One thing you have to understand, our equation has to be in standard form and it has to equal 0. All right, so we're only going to do a couple on here just to kind of go over that. So, looking at number 1, I'm just going to scope in a little bit so you can see it better, hopefully. Oops, sorry. All right, so looking at number 1, I want to go ahead and I want to solve this quadratic by factoring. First of all, it is already in factored form. How do I know that? Because I have the two things being multiplied. So I've already factored it. So I set each factor equal to 0. So 8t equals 0, 1 minus 2t equals 0. Solve. I did my two solves. Now I have to come back and make sure I put my answer in my set notation. So the first thing I need to do, set all factors equal to 0. Solve each mini equation. Answers in set notation. Oops, sorry. Answers in set notation. Perfect. So how is number 3? I'm just going to go underneath it to number 3. How is number 3 different? Number 3 is different because 1, it doesn't equal 0. So I have to get all my terms over to the left so that it equals 0 because that's my first requirement. So I'm going to subtract 9t from both sides. That makes 0. Now remember, it has to be in standard form, so it has to be 9t minus, it has to be t squared minus 9t. So now I'm going to GCF out my t. Because remember, GCF's the first way we factor. Voila, I have two factors. So I set each one equal to 0. Put my answer in set notation. Let's do one more, number 4. All right, the first thing I need to do is bring the m term, the 24m term over. So keeping it in standard form. Remember, you subtract it from both sides. I just didn't show the subtraction. Now I'm going to factor it. So make my t-table. Be careful with my terms. So it multiplies together to give me 144. Well, that would be 12 and 12. But adds together to give me negative 24 means they both have to be negative. So now I'm just going to go ahead and come back to my table. I can use my shortcut or I can use factor by grouping. I'm going to use my shortcut. So m minus 12, m minus 12. Again, it has to equal 0. Set each factor equal to 0. Now, because it actually was a PST, it actually has the same thing. We do not have to, the same answer. We do not have to write the 12 twice. We can just write it once. No big deal. What you have to be careful of is 1, my equation has to equal 0. Then it's just all the factoring rules we already know. And my answer has to be in set notation. The second part of our notes today had to deal with our quadratic formula. With the quadratic formula, again, this is the quadratic formula. It says x equals negative b plus or minus square root b squared minus 4 times a times c, all divided by 2a. What you have to be careful of is, again, it has to be in standard form, which usually it is. The second thing is, how do I come up with my a, b, and c? It all comes from my original equation, where a is the coefficient in front of x squared, b is the coefficient in front of x, and c is my constant. So once I identify those, I just plug them into my equation and chug out my answer. So let's look at number 1. All right, so first identify my A, identify my B, and don't lose the negative, identify my C. Now, I put it into my equation. X, I do not have to worry about a GCF or anything. I just take the original equation, shove it in. So, x equals negative b plus or minus. Plus means I'm going to work, plus and minus means I'm going to work it twice. I'll show you that in the end. Square root b squared minus 4 times a times c, all divided by 2 times a. My second step is I'm going to clean this up. So I'm going to go ahead and make the opposite of negative 6 positive 6. Keep my plus or minus. I'm going to simplify under my radical, which means I'm going to go ahead and multiply it all out. I'm not going to take the square root yet. Why? Because I don't want to make a mistake. I'm going to simplify everything under the radical. I'm going to take negative 6 squared minus 4 times 1 times negative 40. When I plug all that into my calculator, I get 196. Now, at this point, I have two options for my answer. The plus or minus means I'm going to have 6 plus the square root of 196 divided by 2. And my other option is 6 minus the square root of 196 divided by 2. When I work these two options, I need to be careful that, one, if I'm on a graphing calculator, I do 6 plus the square root of 196, enter to lock the numerator together, then divide by 2. Same thing on the bottom. If I have a regular standard calculator, I can just take the square root of 196, get an answer, and just do the math. Just remember, your numerator has to come together to get an answer before I can do my division. So in the case here, I have 6 plus the square root of 196. When I divide it by 2, I get 10 as my answer. I have 6 minus the square root of 196 divided by 2. I should get negative 4 as my answer. Again, I have 2 answers. So therefore, I have my set notation with my 2 answers. Oops, sorry, my set notation messed up there. So where does the problem occur with this? 2 ways. 1, I should always have 2 answers. Unless, 1, when I get to my square root, I have the square root of 0, which I'm going to show you that one in a second. So my square root under my radical actually comes out to 0. 2, when I go ahead and take my square root, under my radical is negative. In that case, I have no real solution answer because I can't take a negative square root. Those are my only other 2 options. I'm going to show you both of those inside of our notes as well. 99% of your answers are like number 1. They're either going to be nice, pretty numbers like this, or they may be a decimal. Because if when I do under my radical, I get an irrational number, I'll have a decimal answer. If time, I'll show you that one as well. So on number 2. Okay, A, B, and C. So A is 1, B is negative 6, C is 9. Plug it into my formula. Three, simplify the math. When I simplify under my radical, the negative 6 squared minus 4 times 1 times 9 makes 0. In this case, the square root of 0 is just 0. So it's 6 plus 0 divided by 2, 6 minus 0 divided by 2. Both answers give me 3. So I'm just going to put x equals 3. I ran out of space, sorry. So my solution set is just plain old 3. Because no matter what, anything plusing 0 is only going to give me one answer. One like number 3, I'll go ahead and do that, and then I'll do number 7. One like number 3 just happens to come up with an ugly radical. No big deal, we're good. So, again, identify my A, identify my B, identify my C, put it into my formula. Oops. Negative B plus or minus the square root simplify my answer. Now, this right here is something we call simplest radical form. Why? Because it's a radical. I can't simplify it back like I did in January, so therefore it's simplest radical form. Some of your answers on your test will take you to here. Some of your answers on the SOL test say which of these answers is correct. They just don't go any further than this. No big deal. It's called simplest radical form. But we can also get an answer with this as well. Because of the fact I can take my calculator again and do 7 plus, no, it's not 7, sorry, it wasn't a 7, that was an x. 7 plus the square root of 73 divided by 4. And I can do 7 minus the square root of 73 divided by 4. When I work this one here, 73 is irrational. Therefore, it's going to have to round my answer. I'm going to get a yucky answer. So 7 minus the square root of 73 divided by 4 correctly on my calculator gives me, I don't have it in front of me. Hold on, I got to use my calculator. 3.89 rounded. Sorry. When I do 7 minus the square root of 73 divided by 4, rounded. So I have ugly answers, and I'm going to have to round them because I have an irrational number there. Big deal. We can do decimals and we can round. Now, the only thing different is number 7. On number 7, you notice that when I'm going to go ahead and get my A, B, and C, I'm missing somebody. You have to remember that my B term is BX. So what is here is A and C. There is no B because C is my constant. So my A is 1, my B is 0, and my C is 10. Does that change my formula? No. Clean up. Here becomes my problem. Cannot have a negative under my radical. And if I try to do it, then I will get what we call an imaginary number, but it's called no real solution. So you would just put no real solution. And if you had the graphing calculator, it'll say error, no real solution or no real answer. I hope that helps clarify. You can look at the YouTube videos as well. Thank you.